Good afternoon and welcome to this live event session on clean steam and steam quality. Thank you all for signing up for today's topic. We really appreciate the great responses to our online webinars. My name is Debbie Robertson. I'm the organizer of this webinar and regional marketing manager for South Africa and East Africa. And I will take you through the introduction. Our main presenter for today is Johan Style. He's our regional sales manager of Western Cape, who is dedicated to assist with customer system improvements in order to generate sustainability for them. And with over 14 years experience at Spirax Sarco, he's also been involved in the manufacturing industry for over 34 years. Joining him today as our guest presenter is Francisco Pedrosa. He is our EMEA steam quality specialist who is really passionate about clean steam and steam quality. His mission is to help engineers, quality managers, and production operators to understand the advantages of switching to a clean steam process in order to create highly efficient, highly safe systems that produces consistently high quality consumer products. So before I hand you over to Johan and Francisco, let me go through some housekeeping rules and procedures. This session will be 2 hours, that will include feedback on any questions asked throughout the session. Your microphones will be muted at all times, so please, if you have any questions, submit these through the Q&A pane. Francisco will then pick up your questions throughout the session and will either answer them or leave them for discussions at the end of the session. Please note that if we do not get to all your questions, we'll reach out to you afterwards and answer those as best we can. This session will also be recorded, so you will receive an email containing the link of the recording afterwards if you want to revisit some of the topics that was discussed. We will also ask that you please complete a very short survey as we appreciate your feedback on the value you receive from these sessions. So thank you. With that, I will hand you over to your presenter, Johan Style. Thank you, Johan.
Hi, Debbie. Thank you very much. Welcome to everyone. And today's session, thank you for using your time and spending it with us. Hopefully we can contribute to your sustainability. Just to give you a bit of background about the group structure of Spirax Sarco. We have 2 thermal energy management companies, and on the steam specialty side, it's Spirax Sarco, which is and Gestra, which is focused on industrial and commercial steam systems. And then on the electrical thermal solutions, we have Chromalox and Thermocox, electrical process heating and temperature management solutions. And then at the side, falling under Spirax is also Watson-Marlow, fluid technology solutions specialists, and Denise peristaltic pumps and associated fluid path technologies. Then just about our global presence, we have operating units in 46 countries, sales offices in 21 countries, and indirect presence of 98 countries. The key facts, we have 10,400 employees, over 2,100 direct sales service engineers, direct sales present in 67 countries, 146 operating units serving customers in 165 countries, 40 manufacturing units in 16 countries. So, looking at our solution and products and services that we present from the steam side, industrial leading range of special steam products, complete and flexible range of services, and customer partnerships which drive quality, efficiency, and your sustainability as well as ours. If we look on the right-hand side, it's a representation of the steam loop, as we call it, starting off with a boiler and boiler blowdown to the boiler controls, and then obviously flow metering and monitoring, then controlling the pressure at your application, and then from there controlling the temperature of the steam to your application, and then from there also steam trapping and pipeline auxiliaries. Sorry, I just want to So yeah, the steam loop also then consists of the steam traps at the application, pipeline auxiliaries, and condensate heat recover. We deliver the most comprehensive products of steam and condensate loop through our global network and steam experts. Steam delivering advantages to the industry. As you can see, there are multiple uses for steam in every single industry of pharmaceutical, food and bev, OEM manufacturing, obviously for those industries, healthcare, waterworks, buildings, oil and gas, chemicals, power generation, mining, and semiconductors, and pulp and paper. The pictures just represent a slight indication of the industries. Almost all items we encounter on a daily basis have the use of steam somewhere in the supply of the manufacturer. What is wrong with the steam plant? Well, nothing for most industrial applications. Plant steam is increasingly becoming unacceptable due to the following things: boiler feed chemicals, pipeline scaling, rust and corrosion particles. And it's especially to this that you actually want to talk to you about today, about understanding the quality of the steam and where it's been used in your processes, to why plant steam is used in the processes. Sorry, I don't know if you can see the actual pop-up that sits in the middle of the screen. Can you assist me, Francisco? What can we see at the moment?
Yes, we can.
Yes, you can.
Can you just close it?
Yeah, I'm trying to. Give me a second.
Or move it to the one side.
Yeah,
There you
That's
go.
it.
sorry about that. Okay, why use it? Why use steam? It's still the most efficient, cost-effective way of transferring heat in all industries. If you consider the controllability of steam, it's very controllable. The temperature and pressures are related to each other, so it's accurate and repeatable in the operation of your systems. The steam is proven sterilizing process. So because of the steam's capabilities, it's a very good option for that. Steam still fills heat transfer space evenly, ensuring consistent quality because of the controllability of it. Then steam is ideally suited to clean and sterile products and environment as it is inherently sterile. Steam is extremely flexible as it can be generated in a central boiler plant or localized boiler, whichever suits the application. That means that I can transfer the heat over quite a considerable distance and still be very efficient in getting the necessary heat at the application. Steam is non-toxic. Due to the qualities of water, it obviously brings a very fast-acting destructive power against microorganisms. If there are any questions, please raise them as we go along. As Francisco and Cornelis will attend to them. We now move to the origin. If you remember the steam boiler loop, the steam loop, we start at the boiler, and that's where it's important to understand what steam you are actually allowing to get to your plant. What happens in steam boilers? Priming, boiler water being carried and forced from the boiler to the steam and condensate circuit is a problem if it is not understood correctly. Foaming in the boiler allowing unstable water conditions, forming raw water issues, chemical issues, and poor quality. In other words, if the pressure drops in the boiler and it operates below the actual design pressure of the boiler, you are going to get foaming and therefore carryover. So that means water droplets formed in a boiler entrained within the steam will be drawn into the steam system, which means that your energy that you will be carrying to the actual plant and where the steam is going to be used will be less than at the saturation point of the steam. Okay, so let's talk about priming. It's a sudden draw of boiler water into the steam takeoff. It's generally due to one or more of the following reasons: incorrect selection, installation maintenance of raw water, pre-treatment plant, operating the boiler with excessive high water levels, operating the boiler below design pressure, increasing the volume and the velocity of the steam released from the water surface. Sudden excessive steam demand will cause priming to happen. And how do we prevent it? FDA standard: control the chemical limits on the steam. Priming is not steam and will therefore contain very high concentrations of chemicals. So understanding the control of your boiler is of utmost importance to start the energy journey. Plant steam contamination, volatiles, substance that can be carried over into a gaseous state, chemical substance, mercury, cadmium, lead, chlorines, chlorides, boiler feed water chemicals, and also can cause harm to human health or steam systems, especially if you have got direct injection systems in your plant. Biological contamination, including bacteria, fungi, viruses, and yeast, present in the water sources and controlled by local water authorities, and concern in the production of medical devices and products which could bypass the human body's natural defense. An example, injectables. High temperature of steam will kill most of these, but in doing so can cause harmful pyroinase happening in the system. Please pose your questions as we go along. Cross-contamination. It's important that we understand in our steam system, in most industries return a high percentage of the condensate. There is a risk of cross-contamination though. Returning your condensate obviously is of utmost importance to get the energy that's still left in your condensate back to your boiler system, into the hot well, back to your boiler. But although we are returning the condensate, it can be a problem if we do a CIP process where there is faulty components and some of those cleaning agents comes back into your condensate return. Also with your processes, with normal heat exchangers, where gaskets fails on plate heat exchangers, and some of these process chemicals or process elements filter through to your condensate return, and then for the same reasons, oil and fats. And this all goes back to your boiler, causing cross-contamination. Here's an example of such a situation. This is a view inside a boiler of a company that manufactured orange juice. And here you can see the process contamination also goes back to the boiler and cause a lot of foaming. As you can see, the top of the boiler here and a water line down below. causing foaming, and therefore that foam being drawn back into your steam system. Okay.
Johan, just one question, sorry. It seems to be a comment, but I think it's just worth confirming. If we feed boiler quality water, there's still chances of various contaminations in the steam.
Yeah, obviously we have to understand the total dissolved solids. Maybe Francisco can also assist us with some better insight into that.
Yes, if I can. Obviously, it's a good point that you've mentioned there. The boiler feed quality is inconsistent in order, and that's why you will see later on the presentation where Johan refers to get that consistency of steam quality into your process. Now, because the variations and the variables that contribute to the contamination within a normal plant steam system, when used direct and indirectly into your process, then the only consistency that one can get is obviously to generate clean steam, and I think that's covered in the presentation further down. If that's not clear further down on the presentation, let us know and we will explain that in more detail.
Oh, thank you, Francisco. I hope the person that asked that question, Cornelis, if that answers his question, if he can just let you know as we go along in the presentation, please.
Yes, if the answer was, and thank you again for posting the first question. We really appreciate the questions. I think this is the engagement that makes these webinars worth it. So yeah, if you feel that the question hasn't been answered properly, please don't hesitate to just repost or maybe ask a different question. But thank you for your engagement. We appreciate it.
Thank you, Cornelis. So the next part of the slides and the presentation, we go on to what is clean steam and the different grades of clean steam. Well, first of all, steam is purer or cleaner than normal plant steam. So filtered steam, this will remove pipe scales, rust, debris, but will not remove chemical contamination. In other words, you have a filter that's a mechanical device with certain porousness, and therefore it will allow chemicals through, but to the size of the porous will keep solids back. Later on in the presentation, we'll illustrate to you on the micronics of the filters to what stays behind and what goes through. Unregulated clean steam, very basic clean steam, chemical free, is an option for some production, but regulated clean steam requires specific purity and quality characteristics according to HTM 2031. And on this, Francisco will at later stage in the presentation elaborate a lot more. Pure steam, similar to clean steam, but the condensate must meet pharmacopoeia grade water for injection. Mostly pure steam is used in the pharma industry. So depending on who you talk to, different industries have different standards, but most use the generic term clean steam. Other terminologies used is filtered steam, potable steam, culinary steam, pure steam, clean steam. And we would like to, from this, actually clarify how steam is being looked at from different grades of use, and also to what extent the steam is clean. Filtered steam is the most common in food and bev industry, particularly by American-owned and influenced companies. Then clean steam may be used in hospitals, medical supplies, fine chemicals, and electronics, and now in the food and bev industry. Now, if you just refer to the food and bev industry and clean steam, if I can just make that connection, imagine you have a process where you're actually using the steam to heat the process, but it's directly injected. Just think about it, that steam, because of you direct injecting it into your product, becomes part of the product as an ingredient. Now think about how stringent you are about water that's being pre-mixed in your ingredients and all the other ingredients that goes into your product. So steam now becomes part of that. Pure steam is used by pharmaceutical, biotech, and electronics. It's have a much higher level of standard in securing that the steam contaminants that's in there understanding to where it's required. So if we look at filtered steam, where it sits on the hierarchy of steam quality or purity, first we spoke about plant steam, which is pulp and paper, petrochem, distilling processes, laundries, HVAC. Now we're looking at food and beverage as part of filtered steam, and then you obviously higher level is clean and pure. So filtered steam is often referred to as culinary steam in a plant with steam that has passed through a fine stainless filter, typically a 5 micron filter. A 5 micron filter element is designed to remove 95% of all particulates larger than 2 micron. Is acknowledged in the USA as being acceptable for culinary steam. When used in conjunction with the FDA chemical standards. Now, it's important that we understand the chemical standards for the boiler, treatment, and the water. A lot of us refer to the boiler chemicals as being food grade chemicals. But the key of that is that to that food grade standard, there is a concentration of that chemicals that needs to be met. If you exceed the concentration of those chemicals, although they are rated as food grade, no longer is the food grade chemical that you put in your steam system. So if you at one particular time and moment measure that concentration and you are within that limits, yeah, for sure, for that moment in time of the measure, you meet those standards of being food grade. But we need to understand that that needs to happen continuously. And therefore, to sustain your food grade rating when you run your boiler chemicals. And you need to ask yourself the question, how do we monitor that? So accepted practices for method of producing culinary steam, number of 609-3, is a standard developed in the USA that establishes the minimum sanitary or hygienic requirements for the method of producing culinary steam. It's important to note that the section on the boiler operating within the 3A practice stipulated that the boiler should be operated in such a manner as to prevent foaming, priming, carryover, and excessive entrainment of boiler water into the steam. So again, how close do you get to saturation point when you're delivering the steam into the steam system, and how close to the designed operating pressure is the boiler running? Because if we deviate from that, then obviously these things will take place. Now let's look at the filters that we put in line. Steam filters removes particles only, solids, does not affect the steam and condensate chemistry, is not designed to remove moisture. The element can be 1, 5, or 25 micron elements. Nominal rating, so only remove a percentage of the particles, 95 to 98%. It's a sintered element. finer particles. Specialist cleaning is required for sintered units, and understand what those requirements are is very important. Francisco, can we stand a bit still on that and elaborate a little bit on that specialist cleaning requirement for sintered units?
Yes, obviously the filter is there to take particulates out. That's basically all it does there. And then obviously some excessive scaling and carryover which forms scales, which then tends to block the filter. Now we get asked a lot of questions and asked how long will a filter last within a system? Now that's very difficult to tell. It depending on the actual control measures of your boiler and the management of the boiler to the actual point of use, which then has variation. So therefore you can never guarantee a element would last you either 2 months, 4 months, 5 months or whatever. Now, obviously, I worked for a company, a food industry company, and my filters were only lasting, it was around 3 to 4 months, and I had to replace it. Now, depending on the way it's actually saturated, a lot of people what they do is they ultrasonic clean the actual filters. What they do is to save some cost. Now, you could do that. There's a lot of people that are doing the ultrasonic cleaning, but it doesn't give you the full 100% performance that you should be getting from the filter. And normally they say ultrasonic cleaning, it could last you in around 4 or 5 times. Anything more than that, it becomes very saturated. What does ultrasonic do? Well, it just vibrates the actual particulates on there, so you don't get 100% performance from the filter. So therefore, it also depends on the actual process. If your process is very critical and the pressure drop is critical, then obviously a filter by ultrasonic cleaning may not give you that pressure drop that you require or that minimal pressure drop that you require. So it's to the end user's decision whether you should ultrasonic clean or not. We would not recommend that for what it's worth and what it costs. It is best just to go for a complete new element. Hopefully that answers it, Johan.
Yeah, thanks, Francisco. Definitely, and understanding the maintenance on the filter, it definitely exceeds the advantages that you get from the filter by far. Condensate trap to be present on the housing, as you can see, the housing has got a very specific design. The steam comes in through the filter and then goes out. So any condensation taking place will go and lie at the bottom of the filter, which obviously, if you look at the laser pointer there, will then the condensate will be removed with a trap sitting at the bottom of the filter. Very important, so that you don't have carryover of water further into your system. High dirt holding capacity with good flow characteristics, but can block easily depending on your upstream quality of your steam. And it is important that these things get monitored so that we make sure that we get the highest efficiency from this. Now let's just have a little look at a 5 micron filter, which is very generally used to remove particles larger than 2 micron, but it's not designed to remove water or chemicals from the steam system. In example, the carryover we're referring to from your boiler. So to the left of the line is what will actually go through, and to the right is what actually will stay behind. So if you just look at the indication, just a few things, obviously guillotine, starch, sugar, virus has got the capability of going through paint, pigment. Yeah, so these protein enzymes. So what will stay behind is red blood cells, pollen, human hair, coal dust, mist, yeast cells, yeah, beach sand, and you'll see on the bacteria scale, there's some that will go through and some won't. But just to give you an indication of at the bottom of what process which you would actually need to remove the particles on the left that is possible to go through the filter is in the end to the extreme is reverse osmosis. So filtered steam, yeah, this is a setup for your filtered steam application. If you look at the main steam line coming in from the left, and you have your stop valve at number 2, number 3 the strainer, and then you go to your separator and the condensate trap, pressure gauge. But once you start going past the filter, it's very clear, understood that what needs to happen beyond point 11 needs to be stainless steel to maintain, not to have scaling or anything like that getting back into your system. So from the filter onwards, needs to be stainless steel to secure that whatever you've removed with the filter will stay out of the system.
There's a question there, Johan, if you want to answer it. Somebody hasn't put his name on it, but it's also a good question for everybody to know. It says, how do you ensure the filter doesn't affect the steam pressure downstream? Well, the only way to ensure that the filter now, that's why a lot of the industries, if they are very critical, as I said to you previously, the only way to get that consistent steam quality and pressure is clean steam. And that will be covered further down on the presentation. There is no way to ensure that the filter doesn't affect the pressure. It will affect the pressure downstream because a filter is there to block any particulates or any carryover or anything that comes through in the system. So that will block it from preventing it from going into your process. So it will always be affect the actual steam pressure, downstream pressure. So basically the solution for that would be a clean steam solution, which Johan will cover further down on the presentation.
Yeah, just to add to you, Francisco, if you look at number 9 on this specific sketch, you have a gauge before and after the filter. So obviously in the initial stages of designing the filter size, it is important that we design the filter size correctly for your steam flow and pressure that you have to cause the minimal delta P over the filter. But as Francisco explained, as obviously as the filter is being holding the solids back, then obviously that pressure differential will increase. So therefore, if you have gauges like in this illustration, we'll have a very good indication of the delta P that's at that specific moment in time within your plant. But yeah, we do design the filter to have the minimal absolute pressure differential drop in the beginning when we size the filter to secure no pressure drop or very little pressure drop. I wouldn't say no, but very little pressure drop over your filter.
There, just to add on that as well, that you made me remind, we have designed systems that we have 2 filters in parallel, which is automated. So what actually happens is when there is a pressure drop sensed down the filter, it automatically has a changeover and switches over to the next pressure, to the next filter housing, and gives you facilities or time to actually replace the actual element while the other one is in situ. So yes, we have designed two parallel systems in line. That will also help, obviously, in a system, filter system or culinary steam system, but we are strongly recommend, because of the contamination issues, we still strongly would actually sort of bound you to go the clean steam route if you want any guarantees from our point of view.
Yeah, Francisco, as well, you can, now we're looking at the sketch, and there is quite a considerable standard understanding that some of these components that's sitting upstream from the filter has also been re-looked at for redesign, because of trying to be compliant with the regulations. Maybe you can elaborate a little bit for us on that as well.
I think we're going to talk about the legislation requirements, and then we'll refer to, as you well said, steam when it's directly in contact. It's it actually classified as an ingredient, and what needs to be done for that, and what are the risks. Now, HACCP, which applies with there's a EU or a legislation, the 852, which tells you the direction one should take, and one of them is applying a HACCP. Here it is here. Do you want me to continue with this?
Yeah, as you are, just to inform our audience, Francisco, our expert in this area, is actually also helped to write some white papers as part of the standards. So yeah, feel free to ask Francisco any questions around that. He is absolutely an expert on the cleanliness and control of steam. Over to you, Francisco.
I'm going to ask you to change the slides as we go along, obviously, because I haven't got control. Okay, yeah, just leave it on that one for the moment. Right, as I've explained, what is HACCP? Well, there's legislation guidances, and it tells you that if you know there is a possible contamination that can occur within your process, then is what we call is the HACCP principles. Now, we do HACCP audits for a lot of the companies. We get asked to do these HACCP audits to try to analyze where are the risks to the current processes. And what we do is we produce a confidential report with the actual risks and also the solutions to overcome those risks. Now, you can contact Johan if you are interested in something like that. It'll probably help you, and that will be a very good first step to start off analyzing your current risks at the moment. Now, when we talk about steam is needs to be considered as an ingredient because it is directly involved or directly in contact with your process. Now, we need to understand and we need to acknowledge, will steam in the current state contaminate your process? The answer is yes. How can you manage that? Well, there's various things you can manage it, and there's various things you can do. Johan was clear enough when talking about boiler carryover, and the chemicals used within the boiler have to be food grade chemicals approved. But there are limitations that you can do. So you can actually try to prevent things from happening, but you cannot overcome it. You can't eliminate it totally. So the only way that one can actually have peace of mind, if you really think that the system needs to be eliminated, or the contamination needs to be eliminated, then you're going to have to apply what we call is clean steam, which will be covered in this webinar closer. How does HACCP actually apply? Well, you start looking at the various risks of your process. Now, when it comes to HACCP, I'll just put a couple of sort of factors that actually contribute to actually generating steam. Now, because, as I said to you early on with that question around the feed water quality, because the inconsistency of the steam that's coming from a normal conventional boiler, Therefore, you have to put measures into place to try to control that. Now, it is very difficult to do that. Now, when you ask some people, some clients, customers, you ask them, are you doing a HACCP control measures for your steam when it's directly in contact with your process? And some of them say yes. But when you ask them what they're doing, basically all they're doing is making checks on the actual raw water going into the actual boiler feed. But that's not the only one that needs. You have to have a HACCP control measures of all the actual factors that can raise a risk to your process, and that takes a lot of management. Whereas if you had to go the clean steam route, then all these factors are eliminated. And for example, you know, when you talk about crevices, dead legs, those all needs to manage and you need to control. And it's very difficult. You don't know when that dead leg or that crevice is going to be accumulated, or it's going to end up with some type of contamination that will end up in your process. So it's very difficult to control. But that's why they put these measures in. Now, I'm going to show you a quick simple what I mean by HACCP. If you go into a production area, for example, into a manufacturing site, whichever customer you go, the first thing they ask you is, and this is how I explain the HACCP in terms of steam as an ingredient. Well, when you go into the area, the first thing they ask you to do is to put a hairnet on. If you've got a beard, you have to put a beard net. You have to put a jacket. You have to put various things. Why? They say that the possibility of you entering that area could contaminate the process. Now, if you look at steam as an ingredient, it actually has the same risks. In fact, it has a substantially higher risk of contaminating the process. Therefore, that's where the HACCP applies. You want to go next slide? Okay. What does it do? Well, as I said to you clearly, it's steam checks that you do, but because the steam changes every second, it is very difficult to control the actual HACCP control measures that you need to put in place. Because if you take a sample of the steam today, or now, and then 5 minutes later or 4 seconds later, whatever you want to just take, it'll be inconsistent. It'll be different again. It actually varies because of the variations of factors that you have, which is on the upstream and obviously the downstream of the filter. So where if you had to go to clean steam, and because of the water quality that's going into a clean steam system, which we will talk about, it is consistently the same all the time. And then therefore you would have the consistent steam quality that you require for your process. Next slide. I can't see, yeah, that well. Okay, this is just a regulation which is normally across the whole of Europe and also in all international companies that apply. And as I said to you, if you follow this regulation, which is the 852, which has been in situ since 2004, and it is implemented as a regulation because there has been issues within industries out there. A lot of people say, well, we've been running like this for 35 years, we've never had, but there has been. The chance can be, who's going to take the risk? Who's going to actually take that responsibility to say that we are risk-free? Nobody wants to take that challenge aboard. Nobody wants to do that. Therefore, we've introduced, and obviously a system that will give the customer the peace of mind that the system they're using currently directly injected to the system is free from any contaminants. And therefore, by applying that is what we call clean steam. Do you want to continue that, Johan?
Okay. No, you can carry on, Francisco.
Okay. So, as I said to you, so the only method that we or anybody can give the end user the guarantees that steam will not be contaminated in any form or matter, then the one has to apply what we call a clean steam. Now, there's very confusions out there. What is actually clean steam? A lot of the people, a lot of customers go, well, you know, do you have clean steam? And they say, yes, we got. I said, what type of generator do you have? He said, no, we got a filter. A filter is not clean steam. All what the filter does, as Johan was explaining clearly, it actually actually only takes the particulates out there of some rust particles or whatever that is less than 5 microns, and it's actually captured in the actual filter. But if you have excessive chemical carryover, or you have other contaminants within the actual the steam line, that will actually find its way through the filter into your process. Johan was talking about condensate return. A lot of the condensate in a industry like yours, it actually gets returned back, and that carries a lot of contaminants. Now, if you apply what we call HACCP, one of the HACCP control measures would be to actually clean out the actual feed tank to the boiler. Why? Because if there are contaminants in the feed tank, that could actually land up in the boiler, and the boiler will generate whatever the actual contaminants are in the feed tank. It is quite simple to understand that if your feed tank is contaminated, then the rest of your steam is contaminated. You don't have to be a professor to understand that. It's a circle, a loop that keeps on contaminating, and unless you remove the contaminants, it'll always be there. Now, if you apply clean steam, as it clearly says there, the water that is used within the clean steam generator, which is an independent generator, is reverse osmosis. What is reverse osmosis? And I think Johan also referred to early on as chemical-free steam. Now, when you refer to clean steam, it's always referred to as chemical-free. Why? Because the water that's entering the clean steam generator is removed from all the chemicals. So in other words, the RO removes the smell, the taste, the odors, then the chemicals that's in the water, and that water generates the steam. And later on we'll have a P&ID on how a clean steam generates, so you can understand that better. Now, clean steam is the only guarantee that one can actually give you to have that consistency. Now, the clean steam and the condensate from the clean steam never gets returned to the clean steam generator. Why? Because there is a risk of contamination. So therefore, you return that to the boiler. Now, we always want to clarify this. As you can see on the triangle, you have the filtered, clean and pure. Now, there's a lot of people, when you ask them, it says, what type of steam? No, our steam is pure. No, it is not pure. There's different angles that you need to understand. And we like to mention this, even though it's not relevant to the actual food and beverage industry, but it's very important that you understand that there is one higher than clean steam, and that is pure steam. Now, pure steam doesn't apply to the food and beverage industry at all. It is a pharmaceutical, and it's very legislated. So therefore, it actually more into that industry. That's why a lot of you can say wherever you manufacture tablets or manufacture medication, you know that the steam is consistent at all time. Doesn't matter whether you do it in South Africa, Japan, Europe, wherever, because of the legislation requirements that follow through in the pure steam. Now, the same thing the food and beverage industries are actually doing, and they're going what we call clean steam, which is a steam used which is chemical free, and that will not be able to contaminate your processes. Is this for you now, Johan?
Yeah, Cornelius, are there any further questions?
No fresh questions, gents. I think we're doing quite well. Thank you.
Okay.
Just time check. We've got about an hour and 10 minutes left.
Yeah, no, we got that. We are about just over a third done. So I think we are doing good for time. Francisco, this is the typical requirement and uses for filters and clean and pure steam. So I think this is in referral to the finishing of the products that's now been upgraded.
Yes. Okay. Look, a lot of those standards you see there are standards that we generally use within, whether it's food, whether it's hospital or pharmaceuticals. Now, when you want to quantify any product that's actually in contact with food, it actually has to be obviously stainless steel. There is, next slide, there is some legislation requirements that something that you need to understand. These are just some applications that you can see on the screens which are used directly steam in contact with the process. They may or may not follow your manufacturing process, but just to give you an indication, there's lots within food where steam is directly in contact. Now, I also would like to cover, if you understand, if you take, for example, a can of tomatoes or whatever, and steam is part of that, where it's directed into the actual process, you will see there's a label on the actual can of tomatoes which says the ingredients that you use within your process is actually clearly identified. Now, you should, by right, identify or actually declare that the steam, because it's directly in contact, you should actually declare what ingredients the actual steam carries in order to actually be safe from the process. And therefore, using clean steam, as I said to you before, it doesn't have to be declared because steam has got nothing into it, and therefore it doesn't have to be declared. Next slide.
Francisco, can I just add to what you've just said?
Yes.
So a lot of the time, we might not blow the steam directly into the product to mix or to heat as such, but a lot of the capper machines utilize the steam just as a blow-off before the caps of some of the containers are being fitted. And do understand that that steam actually then also comes into contact with your product. So even at the very last stage, where you are manufacturing your product, steam can also then become part of your product that you have got in your container in that regard. So it doesn't necessarily mean that the steam has to be blown directly into the mix while you're mixing the product or heating it. It also can be at the very last stage at your capper machine.
It's a very good point, and I think we're going to cover in some of the case studies that we've seen further where the actual applications, because we talk about steam when it's directly in contact, either through sterilization, and as you well said, when you use steam for sterilization or use steam to sterile your pots and pans or whatever you're using, that steam is in contact, because not just because of the contaminants in the steam, the problems that we are having in industry facing nowadays is actually the smell and taste that's actually occurring within the actual steam that's happening in a lot of the industries at the moment. So it's the taste and taint of the chemicals and the materials that's been used upstream or from the normal conventional boiler that's actually causing these contaminants. And that's where the major thing comes in, because if you take, for example, and you yourselves is more a question to everybody, if you take a condensate sample from your steam line, your conventional steam line currently, and you ask your colleague or yourself, you take a sample and you ask, would you like to drink the sample of the steam that's going into your process? A lot of them will tell you, no, I don't want to taste that, I can't taste that. You see, it's the perception that people understand, yet they are putting it into their process. So those things we need to consider, and that's where, again, to have that safe and peace of mind is to move into a different route, which is the clean or chemical-free system, which we'll introduce further in this webinar. So these are the contaminants that occur within, and the major ones that we said to you today, it's happening is the taste and taint, which is causing a lot of product issues and a lot of product recalls. Next slide.
Okay. Product and quality, purity standards. This is where you really excel in, Francisco. So, as we said before, the steam quality commonly refers to only the amount of water in the steam. So the dryness factor equals the mass of the steam, but the mass of the steam plus the entrained water is equal to the dryness factor. So, Francisco, steam purity, how do we quantitatively measure that?
Well, This is interesting, and I'm glad you've actually put the slide onto here now. When we talk about steam quality, we must understand there's two things. There's the health and safety around steam quality, and there's the food safety around steam quality. Now, we haven't really spoke about the health and safety point of view of steam quality, because if we talk about dryness fraction, a lot of people you ask, do you know what your dryness fraction is of your steam? Do you know what the wetness of your steam is going into your process? A lot of people don't know that. Now, Spirex has invested in a lot of money within the this type of subject, where we can actually measure your steam quality and understand what your steam dryness is. The benchmark in industry for any processes, and in terms of health and safety and also food safety, they say that you need to achieve around 95%. Now, if you don't understand what your dryness is, let us talk to us and we will come and put our equipment in there and we can actually measure. If your dryness is not 95%, we'll be able to provide you solutions to overcome that, to make sure you can sustain the 95 value, because inconsistently of your steam varying in dryness, that will actually vary your process conditions as well, because wet steam changes temperature. It can add extra unnecessary ingredients into your process. So therefore, it is best to understand or to have a benchmark. Talk to us and we'll talk about that. Steam purity, when we talk about steam purity, is more about the carryover, the chemical content, and the actual the substances that actually have in the steam that we cannot control, or we can put it this way, we can manage some of it. So that's why we always strongly recommend, if you need any guarantees in terms of the purity that you're looking for, going into a clean steam, into a process, then clean steam system or a chemical-free system would give you that peace of mind that the purity is consistent at all time. When we talk about quality, then you always reference the non-condensable, steam dryness and superheat. Non-condensable is just as good, just as important, both for your equipment downstream, because it protects your equipment, and also if you don't remove the non-condensable, what happens? You get excessive corrosion within your system, and that obviously starts to contaminate your process even more. So let us come and do that, and the actual steam quality will understand what your non-condensables are. We'll check the steam dryness to make sure that you have the benchmark, and obviously take measures to ensure that you have that consistency of the non-condensed superheat dryness in accordance to industry standards. There's a lot of mechanical correctness that one has to put upstream and downstream to make sure that you meet that consistently. When you talk about the purity, obviously that becomes a very difficult measure to control when you've got a conventional system. That's why going the clean steam route, the purity is always consistent. Next slide.
Yes, Francisco, before we move on, the next slide is about the legislation and the guidance. But I also like to refer to the steam dryness test and why that is important. Dryness is also important in your thermal efficiency of your system, because if you have 80% dry steam, it means that 20% of whatever runs down your system actually is water. So if you look at the enthalpy of that steam, of saturated steam, it means that you lose of the possible energy that you will bring to your process, that you only bring 80% of the possible heat exchange that can take place at the point of use. And then also, obviously, getting rid of that water downstream as it collates to prevent water hammer in your system, which is a safety risk. So dryness of steam is of utmost importance. And then non-condensable gases also interferes with the capability of heat exchange in your heat exchanger, because if you have gas, a different gas, as steam is the gas form of water, But if you have different gases sitting there, occupying the space and not allowing the steam to get to the plates of the heat exchanger, having the ability to give off the latent heat that you're trying to induce in your process, the non-condensable gases will restrict that. Then obviously also superheat interferes with the heat exchange into your process because of superheat steam not being that willing to give off the heat that it carries. Does that make any sense, Francisco?
Absolutely. And that's why I said it's so important. And like we said, there's industry benchmark that we do apply best practice to. And as I said, the mechanical correctness of the system, a lot of people try to compromise on the system and cost. Ultimately, as you well said, and I said it as well, there's two things that we need to understand is the food safety point of view, the risk that has to the food, and also to, the health and safety, which is just as important. And those two, that's why you need to apply the right mechanical correctness of your steam system. Do not compromise on the steam system, because ultimately either somebody's going to get hurt or you're going to get repercussion on contamination in your process. Let's just cover quickly legislations and guidances. These legislations and guidance are there to help everybody to try to make sure that what they are doing is actually safe for human consumption, and also not just necessary for human consumption, it is also there for animal feeds and such processes as well. The same applications apply. There's two, if you just click on the slide, the two other legislation, click on the slide, yes, and the next one. The two legislations that I'd like to cover now. I know possibly the 1935 would not reflect to South Africa content, but let me explain to you that 1935, if you are producing foods within your country, which is outside the EU, and you're exporting to the EU, then the 1935 will be applicable for you to make sure that you use that 1935-2004 legislation. Now, that 1935-2004, it is not a nice to have, it is mandatory. If you are not doing and you are exporting to the EU, I suggest you actually investigate further what that legislation really requires. It requires a material certification to ensure that any materials that directly in contact with foods does not allow any odor, smells or chemicals that can possibly contaminate the end process. So it's very critical one understands that what that 1935 actually, and in order to be fully compliant to 1935, then a clean steam system will give you that full compliance requirements if you want to go that route. The one that we cannot plead ignorance or you understand that you or try to weigh the risks, it is the HACCPs. Now, somebody has to take the risks. Somebody has to take the responsibility to say, I did it. I said it was safe to do it. Now, nobody wants to be in that position. So therefore, you apply this HACCP. If you are not sure how this HACCP actually works within your process lines, speak to us where we can actually come and do an audit of your process, and we'll identify those risks to your process with solutions to overcome the risk or even minimize at ultimately what you are doing currently. This is so important that you understand the HACCP. In a court of law, if something goes wrong within your process, they're going to ask you what legislations have you applied. If you say you haven't, say why didn't you apply that? You know that it's available, therefore you need to do. If you know anything better, then you do apply that as well. But it's all there to make sure that the food is safe when you process it for human consumption. Next slide.
Can we just ask Cornelis if
yes,
everything is good?
Yeah, we got some questions which I'll try to answer as much as I can. The first one is, does it mean that superheated steam is more pure because the degree of superheat plays a big part in steam quality. And I said that the chemical composition, because it is closed, the purity doesn't change just because the temperature changes. The next question then is about, are there devices to check on steam quality? And yes, of course, we have Spirax Sarco can come out and we can set up a steam quality test for you, where we would check for those 3 elements, which is superheat, incondensable gases, and of course dryness fraction. And then there is another new question that was posted, which says, is there a gadget that can trap chemical traces in the steam, especially those used as scale inhibitor and oxygen scavengers?
No.
Yeah. So
no, there isn't such thing, and that's why we developed the solutions to understand that if there is any traces, is a chemical-free system, which is the Clean Steam system.
Yeah, so we'll definitely explain. As Francisco refers a lot to Clean Steam, we'll show examples of how to generate clean steam in the rest later on in our presentation. We've got a couple of case studies also to illustrate that. So then you absolutely don't need to worry about having a device detecting anything, and the device might fail and you miss and have the risk back again. So yeah, we have that probabilities that we need to eliminate. So Francisco will explain. But the next
also, sorry, I just want to make one more point. The steam quality test for that first question that I mentioned there, the steam quality test that Spirax Sarco conducts gets conducted by a technician that has been trained and certified by City and Guilds in England. So they go through a whole big rigorous training session, lots of tests, lots of results, lots of test writing, lots of theory, etc. about it. So the guys that do conduct these tests are pure professional in it. So I just want to mention that as well.
Yeah,
very good point.
Just a quick one on the chemical traces of steam. Now, there isn't a system that can measure the consistency of of chemical carryover within the boiler. You can actually take a sample, but that particular sample you take, it is that spur of the moment, because as I said to you, steam changes every second. So yes, you could take a sample of the steam condensate and actually have it analyzed, and that takes a while. If you are interested in that, I can tell you what to look for. Normally people look at analyzing the quality of the steam in terms of purity to that of drinking water. If it's safe for drinking, then obviously they're happy. But remember, as I like to stress, that it is that spur of the moment, that second that you take that sample, that's the sample that you're analyzing. As soon as you walk away from that, that changes. That's why we refer to a chemical-free system, which is consistent every second.
Okay, so Francisco, the next part is water treatment, as we start with the water that gets put into the system. So yeah, if you can elaborate a little bit for us on that.
Right. What's interesting is I like to just explain to this. Obviously, the water is the major commodity out of the whole system, because if your water feeding a particular boiler or generator is contaminated, then it makes all sense that the rest of the steam is contaminated. One thing around clean, you must understand that the water going into it's removed from all the chemicals within the system. Therefore, the water is not contaminated, so then it cannot contaminate the clean steam system. But the one thing that you need to understand as well, that the clean steam system or generator is manufactured in accordance to food grade standards. So all the food grade standards are applicable, like no crevices, no dead legs, no the seals or the contacts all has the certification requirements that you need to quantify it for actually food grade equipment. So it all qualifies into that category, not just the actual water going into it. But if you take, for example, dirty water and you generate steam, you generate in a clean steam generator, you generate it with dirty water, then you're going to get dirty steam out of the generator, obviously, because it'll contaminate the actual generator. That's why it's important to understand the water is the main commodity of actually generating that steam quality into your process. Next slide. This is just to give you an indication, as even though, and I think Johannes covered it in his presentation on the previous slides, where it says, even though that your steam or your chemicals used within the steam has to be food grade, there are limitations that you can exceed. Now, as the question came up from Vincent, where it says the chemical, now it is very difficult to have a measurement today to measure your chemical carryover, your chemical resolution within the steam system, because there aren't any system that can measure that continuously. So therefore, to have peace of mind, again, you use a chemical-free system to eliminate that contamination of food. Next slide. These are just legislations that we were saying, because it clearly says in the guidelines, if you know that there's any additive or whatever that is, or anything in the amount of steam that can possibly contaminate the food, then you need to apply what they call, it refers to back to the HACCP principles. And also you need to understand that if, you know, whether we like it or not, an existing conventional steam system will contaminate it, is the percentage of contamination that will occur. Somebody has to take the risk. Somebody's going to say, we can live with that risk. If you can live with that risk, then it's fine. You continue to do what you are doing. But if you want to eliminate the risk, there sadly is only one solution that one can apply in that system. And this is where these legislations come into, is to give you that guidance. If you know there are systems today that can actually prevent you from contaminating your process. This is just to give you some of the, if you are using some of the these chemicals on the left, is to show you not to exceed. For example, the very first one, do not exceed 10 parts per million in the steam. Now, it is very, very difficult to control that. In part, it's probably not possible to control it. How does it work in a steam boiler? Well, you got dosing pumps in a steam system, and your dosing pumps will be dosed into the actual feed tank to accommodate whatever the resource you're using, whatever the chemical is. It could be for oxygen scavenger, it could be for corrosion inhibitor, it could be various chemicals you use. Now, just to give you an indication where I'm talking about how difficult it is to control that limitation is, once or every 3 weeks, you'll have a chemical guy that comes and checks your water treatment within the boiler, and he suddenly says, well, we need to raise the oxygen scavenger chemical slightly more because we found that it needs more. So what he actually does, he actually increases the dosages of the pump into the actual thing. 3 weeks later, he comes back and he says, I think we overdosed the system. We now have to turn it back. And all he does, he turns the ingredients or a notch further back from 3 down to 1, and shows you the inconsistency. Where's all that excessive chemicals gone? Well, it's gone into your system. And that's why we need to, or it's been developed, what we call a chemical-free system to prevent those issues from happening, or those risks from occurring in your process. Next slide. I'll talk about different types of water treatments there are. The one that I'm going to concentrate today or talk about is reverse osmosis, which works in conjunction with a clean steam generator. So what the reverse osmosis do is actually to remove all the chemicals, all the odors, all the smells, all the tastes from the actual water prior from going into the generator, which is generating chemical-free steam to your process. Next slide. Okay, that is the reverse osmosis system. What it actually do, how does it work? From the left, we start off from the left, you have 2 blue cylinders. Those are called water softeners. From the water softener, it passes the water softener. That's a dual system. So when one is in operation, the other one is in generation. And then you got another cartridge filter, depending on the chlorine contact of your process, that is actually sized accordingly. And that carbon filter that you see there, or carbon cartridge, you see that it actually removes the smell and the taste and the odors in the actual water prior to going through the membranes, which you see on the right hand side, those two stainless steel upright vessels. Those are your membranes. Now, a lot of the water is it's determined between the concentrate and the permeate. The actual concentrate goes down to drain, which is around 20% of the water that's coming into the RO, and then around 75% plus is the permeate, which is the water, which is the chemical-free water that goes into your generator process to generate the clean steam. If you look on the charts that we have here now, you will see on the left-hand side, that is the water quality that we suggest, or the benchmark industry standard for the water requirements going into a clean steam system. That's on the left. On the right is the sample that if you are applying what we call clean steam in reference to a clean steam generator and an RO, these are the standards that you take. So in other words, if you take a sample of the condensate, you measure it to those measurements or those chemical reactions you see there. Now you see there, they talk about heavy metals, talk about calcium, lead, chlorides. Those are all contaminants that can occur or can be transparent in your process. Now, a lot of industries don't check for all those. The other one that you see on the top, which is the quality, we referred to the dryness, non-condensed superheat that we were talking about, which again, we will come and measure, and using those benchmark. If those benchmarks are not achieved, then we'll change the mechanical correctness of your equipment to make sure that you actually can reach those quality standards. Materials of constructions, next slide. It is very important you understand, if you are using filtered steam, then it is acceptable to use what we call 304 stainless steel, and everything after the filter has to be 304 stainless steel. If it's not, you defeat the object of the filter because it's there to take any particulates upstream from the filter. If you are using clean steam system, then we highly recommend that you use anything that's in contact from the generator to the point of use. It's all in 316L, and all the generators that all the solutions that we provide would be 316L and certified to 316L. Water going into the generator, as I explained to you, you remove all the chemicals, so it becomes very aggressive. Therefore, it starts attacking any lower materials than 316. Next slide.
Yeah, just on that point, Francisco, we talk about galvanic corrosion. So if we try to take a shortcut and then try to incorporate some other metal, carbon steel, whatever, cast iron, into the rest of the system, then in introducing that material into a stainless steel system, or that should be stainless, also then actually creates corrosion instead of trying to keep the steam clean. So as we have two metals then forming a chemical reaction towards one another, similar to a battery, I nearly wanted to say, and the one will attack the other and actually manufacture corrosion instead of preventing it.
Absolutely, it's a very good point. You mentioned that. I haven't mentioned it, but yes, it is very under. That's why when we do the HACCP, one of the things we measure is the mixture of the combination of material, which can actually cause problems downstream. Again, just to elaborate on the finishes, when it's normal filtered steam, there's no standards really in terms of what it actually needs to be in terms of the surface finish that's in contact with the process. Where it comes with clean steam, there is some standards where they either mill finish, or even sometimes people request a 0.5, 0.8 micro RA, which is referred to the surface finish. When we talk about pure steam, there's no a way around it. You have to have either 0.4 or less in the surface finish, but it's not applicable to you. Just click again. These are just two applications which I like to. A lot of the installations that I did, because I used to be doing projects across the Europe and across the world for my ex-employer, and I actually these are some photos that I actually took of installations which our installers said it is all clean and it's all to food grade standards. If you look on the left, those what you call welds, and that's a high risk for contamination. So yes, we maybe can put clean steam systems, but if you do not do the proper welding, as you can see on the right hand, then one can actually have further contamination downstream, even though that you have a full clean steam. That's why it's important that you understand and you make sure that you do the installation compliance to a clean steam system, not just on the clean steam generator. Yes, some clean steam distribution methods and examples. You want to cover this, Johan?
Yeah, no problem. So yeah, in our system design, we need to make sure that there are pockets and fitted with a trap set, which consists of isolation valves, strainer, and a steam bypass sensor, as well as the trap, and also your non-return, and then also the further isolation valve. Now, the importance of having a pocket is to allow rundown when the system stops. We want to drain all possible liquids out of the system. If we do not create this pocket, obviously there's not enough room for the water to come and collate in. And then when you start up the system, what you see in the second drawing will just happen, and it will pick up the water and form a water slug that will obviously cause big damage with water hammer. Then looking at your system design, when you have a change of pipe diameters, it's important that we do not use a concentric reducer, but use a eccentric reducer, so that there is one straight path for the condensate to run and go into your pocket, instead of creating a little dam with a slight wall in it. Again, when you start up and the steam starts flowing through the pipes, that it doesn't pick up that water to create a water slug. The next thing is in your distribution system. So when you're going uphill, utilizing vertical risers to enable you to drain the water from the system the minute you shut it down, so that you don't have water in your system when you start up. And then the angle that you need is a ratio of 1:100 in the direction of flow going uphill, and then obviously having them 30 meters apart is very important to have that as a minimum standard. Then distribution design, air removal can be prevented in the system due to ineffective degassing. As you start up after periods of inoperation, you need to have an air vent to get rid of these things, and air can act as an insulator, affecting the sterilizing cycles and also of heat exchange. It cannot infer temperature from the system pressure, and air can influence corrosion. So air in your system is, again, it's another gas that sits with steam that is not conducive to your system being very effective and efficient. And then we keep on referring in the beginning of sustainability. Well, you pay a lot of money for this system, and the longer it can run for you, obviously is important, because it's a big investment that you make to the infrastructure of your factory that you want it to happen. Now, there's also illustration here of the difference that air in your system makes. In other words, 25% air will actually drop the temperature of your steam in your steam system, due to the fact that you don't have fully saturated steam covering the whole pipe, and therefore you will measure the right pressure, but the actual temperature of the steam running through the pipe will not be the correct saturated temperature due to the air sitting in your system. Right, Francisco?
Yes.
The components that we spoke about earlier.
Yeah, you can just go through just the various. These are some of the products that we have available just to give you indication. If you look at all that, it's all nice and shiny, and most of those products that you see, because it is actually designed and manufactured to suit a clean steam system, it actually all in 316 stainless steel and has the requirements of certification that one actually needs to go into your process line. So it gives you that peace of mind that that piece of equipment that you have purchased, it is safe for production of your process, and you have all that backing and certification required for your process. These are just some, these are called separators. Now, a lot of the people were talking about dryness, removing some of the dryness from your system, or actually getting a better dryness in your system. A lot of people eliminate these things. They don't think about how effective this can actually be for your system, and why they don't put it in, because they feel that it's going to add cost into the system, but ultimately it's giving you a better quality. For what it's actually worth, it is worthwhile putting in, and that's just a separator.
Yeah, just to add to that, Francisco, we must understand that depending on the quality of our insulation around the steam pipe, the steam does give off heat as it travels through the pipes, and condensation will take place. So you need to have the most saturated possible steam at the point of use to get heat exchange to the best of the ability that the system can offer, or the best quality of steam that you would need at the point of use. And therefore, the separator is important, because water does not just run at the bottom of the pipeline as illustrated in the previous sketches, as it's just an illustration. The water actually gets picked up and thrown around the pipeline, which then also says to you that a pocket alone is not enough to prevent the moisture from running past the pocket, because it binds to the, it's got a cohesion attention to the wall, and therefore the flow of the gas around it will push it past the pocket, because if it clings to the sides of the wall, it then needs a separator before the point of use to induce a centrifugal action and force upon the gas flowing to get the solid particles to get dropped out by the separator. So it's quite critical to put a separator into your system, especially on a running system, because the pocket is mostly there for when you stop the system to drain it, so that you don't have excessive fluid sitting in your pipeline. And the control valve, Francisco?
Yeah, these are all sanitary type control valves which you can use for either in the steam or in your process. So just to give you an indication that obviously we have a complete solution, obviously not just products, but a complete solution provider. So if you let us know what your issue is, we will come and assess the problem, and we'll come and try give you a complete solution, turnkey solution to overcome the issues that you're having. So these are just some of the products that we have available for whatever you need, whether it's actually on the plant steam or on the clean side. We can help you on both applications. This is what you call a sample cooler. A lot of people fit this just before or close as possible to the point of use, where they take a sample from the condensate. You either have a taste test or smell test, or even you have a purity test. And this is something that you might be interested in. So what this actually does, it just takes a sample of the steam. This is what we're talking about, filters, and you can see on the top is where an air vent is, and the bottom is actually a trap on the actual. Just remember that you have to take the air vent and trap the actual condensate that's accumulated in the actual filter. Steam generation. Yes.
Sorry, we just have a question quickly. Yusuf, thank you for the question. The question is as follows. Reverse osmosis filtration systems are quite expensive in relation to ultrafiltration systems. Are ultrafiltration systems suitable or sufficient to treat raw water being used to feed the boiler? Obviously, softeners will still need to be used.
Yes, remember, when you talk about boiler, hopefully is referring to the actual plant steam boiler. So the plant, even though a lot of people use ultrafiltration in boilers, that's more to have an energy saving, but you still add chemicals into the boiler to prevent it either from oxygen scavenger or from corrosion or pH control or whatever. So you still have dosing system where when you come to a reverse osmosis, what we actually say, or the quality of the water going into a clean steam generator has to be like the actual graph or the table that I had showed on the slide there. There are other ways of methods that you can use, not necessarily reverse osmosis. There are other systems that you can use that will give you the same quality of reverse osmosis, as long as you remove the chemical contents that we say it needs to be removed, and the purity of that water is equivalent to that table, then it's acceptable to go into a clean steam system. And you remember, in a clean steam system, there's no added chemicals into a clean boiler, into a clean steam generator. Okay.
Thanks, Francisco.
Okay, this is just quickly because I'm conscious about time. This is what we call culinary steam, filtered steam. Please do understand that this is not a clean steam. All it is a filter. Normally they put the filter as close as possible to the point of use, and thereafter it has to be in stainless steel. Is there a risk? Yes, there is a risk still to the process. The individuals need to determine what is the risk. If you had to come to us as a solution, or you want a solution which is actually risk-free, then obviously the only one we could offer is the one on the next slide, which is what we call clean steam generation. These are some of the generators available. Some of them are custom made and to suit the customer's requirement, but we normally have we do a feasibility study to understand the process, and then we provide the best solution for the end user's system to make sure that he gets the best out of the system. This is basically how it actually works, so you can have a quick indication when we talk about clean steam, what it actually is. If you see on the top is what we call a degassing tank, removes all the non-condensables from the tank. The water that is being fed into the tank is reverse osmosis, or what I said, it's the quality of water that we recommend that goes into that, which is specified on the table that I showed you on the slides. That is the water that we qualify as clean steam. That water gets heated by a secondary measure, which you can see, it's a plant steam. that plant steam coil that is indicating your one with the arrow, that is all in 316 stainless steel. So the water is in contact with the coil, which is all in 316. So there's no way of contaminating that water in any one way. It is the temperature in that tank is raised to about 80, 95 degrees. Up to maximum of 95 to try to remove all the non-condensables out. When that water is that temperature, it is automatic, it gets pumped and into what we call the generator, a second generator. That generator is also fed with plant steam, which is in the same profile with a stainless steel coil. That condensate that comes out of that coil goes back to the boiler house, the same with the coil on the pre-degassing tank. That bubbles up. We have what we call a diffuser plate, which is there on the top left-hand corner, is a little diffuser plate. That's to prevent any droplets or any things that can be accessed into your steam. And then the steam quality and purity is guaranteed consistently. The steam leaving there is around 98.9% dry, so it far exceeds the industry standards that are there. So if you want a system and you want a system to be free from any contaminants, this is the only system one can actually introduce into it. Now, normally they put these systems at closest possible to the point of use in your production areas, or because it's small, depending on the actual usage. And that also what we call is chemical free. So the steam that's generated from that clean steam generator is chemical free. And even though that it is high purity water going into the actual, it is still, we still blow down to make sure that if it doesn't get used, the water in the generator gets replenished with clean water consistently. So there's never any TOCs or whatever can actually accumulate in that system. It blows down automatically. It is set by the PLC that you can see on the far top right-hand corner, the PLC, all controlled. Is there any questions around how you generate clean steam?
Nothing, Cornelius?
Nothing in the chat section.
Okay, so I'd just like to add, Francesco, we talk about sustainability and heat recovery. This is just a very basic schematic drawing of how to generate clean steam. We do have systems where we utilize the blowdown energy and the condensate return energy to preheat the water flowing into your clean steam generator, so that we don't lose that energy in the process. So there are a couple of efficiencies that we implement into this drawing, but not to make it too complex, that we'll design at the application as the clean steam generator for the customer.
Oh, yeah, one thing I haven't included that you can see from the PNID that there's no condensate return into that system. Any condensate that's developed from the clean steam distribution system, it is all going back to the plant steam, the boiler house. Everything goes back to a boiler. Now, this is what you call a steam-to-steam generator. There are also what we call electric steam generators. So instead of plant, it's electric generators. Okay, this is what it actually is. It's reverse osmosis, as I explained to you. The picture you see on the top right-hand corner, that is the new clean steam generators manufactured by Spirax-Sarco, which has a patent onto it and gives you the same indication and the quality of steam that's required. Now that full system is actually compliance with the FDA standards. It's complying with the E852 and is also compliance to the 1935-2000 FLU. So everything, all the compliance requirements that you need to make sure that the system is food safe, that generator carries that certification. Okay. This is just like to identify, as I said to you at the beginning, if you're are interested and you want us to apply or try to help you identify if there are risks in your current process, this is actually a very good step to start, because it's a confidential report that we share with yourself. And as I said to you, we provide the solution and also the risks associated. The risk is normally prioritized between 1 and 5, where 1 being a high risk, 5 being a low risk. And we give you solutions to overcome that or even minimize that, depending on, we'll work together with you to find out if you want to proceed with that. That's a very good document to have. You know, this is always I like to highlight this. You know, let's not wait for circumstances to happen. You know, let's not wait for product recall. Let's not wait for if something does happen. And there has been some company that I know of that had a reputational damage because of contamination in their system, in their process, and they had to even sell the actual company and rebrand the same product with a different name brand. And the only way to look at that is obviously Clean Steam would give you that peace of mind that those circumstances will not occur. Here's some examples for you. Here's a brewing which they use for sterilizing. They use the sterile air filters. They use the filters, use Clean Steam to sterilize the filters, and also they use the barrels in the actual. This particular uses the beer barrels. They sterilize the barrels with Clean Steam to make sure that if there's any smell or taste from the steam, it'll not appear onto the barrels. And there is a case study towards the end around a company that was prepared to give us some feedback on the Clean Steam generator. They also use it for CIP. What happens with CIP, a lot of the companies, they purge with treated water, but they found that treated water doesn't get into all the crevices and all the dead legs. So they found that steam, purging with steam, gets into those crevices and those dead legs, which they weren't getting before. So it helps them quite a lot into making sure that after CIP, it is safe. You can see by the processes as you can go along, a lot of them are sterilizing, a lot of them are purging, a lot of them are used for sterilizing the caps before going onto the bottles. There are, you can see, for example, you know, you can tell which company that is. They use it for cap sterilization. They use it for sterilizing of the straws before going into the actual sachets. The one interesting thing there's activated carbon filters. They found that using backwashing on activated carbon filter, there were still 2 bacteria that was causing problems. And this bacteria, the only way they could get rid of this bacteria was through steam sterilization. It's something that you need to look at if you are using activated carbon filters. A lot of the companies are using activated carbon filters to take away the chlorine smell and taste from the water. And if it is that you are using it, it is worthwhile looking at your process, because Clean Steam is what we highly recommend to overcome those issues that you are having. You can see there's lots of companies going out, and lots of the companies that, when they do understand that steam is directly in contact and it is considered as an ingredient, then they actually take measures to make sure that contamination cannot occur. This particular design that you see here, before we end off, this whole plant room was designed by Spirax-Sarco in conjunction with the 1935-2004. So every contact steam contact parts that's on this generator has that certification, and it is all in conformance with the EC 1935. So yes, we can design the system to suit your requirements. Whatever the legislation requires, we are there to make sure we are complying with that legislation. Next slide. That's the end. That's the last slide. If there's no questions, you can see clearly this. I'm sure you're familiar with the bottling, or the Guinness, the drink that's here, and there clearly says that before they were using what they call plant steam, or black steam, they were getting some taste differences, not all the time, but it was inconsistently in the actual beer manufacturing. But since they've changed over to clean steam, their beer or their taste has perfected, and it's consistent every time they manufacture their process. So it's interesting to say this, to see and to understand that how the difference that clean steam can make to your process. Now one has to make a decision who's going to convert to clean steam or not. Thank you very much, everybody. I don't know if you want to say anything or if there's any questions there.
I just want to say thank you, Francisco, for your contribution and your knowledge. I'm sure some of the customers that's with us today will meet you as we engage with them on their ASAP assessments or steam quality assessments. And yeah, thank you very much for sharing. And also, Cornelis, thank you for looking after us at the questions. Obviously, we have the 15 minutes we have allocated for questions. Are there any still outstanding, Cornelis?
Questions, no fresh questions here. We had a few really good questions. I just want to say thank you to the audience for spending some time with us today and for sharing some really good and insightful questions. And we hope we answered them properly. But if not, and if there are still some discussions that you'd like to have with us, please feel free to phone or to contact your local Spirax SARCO branch office, whether it's the sales engineer that you may have a relationship with, or you can find us on the internet. But yeah, have a discussion with us. We'd happily come out to site, maybe assess the situation and see what might be required. So thanks again, everyone, for your time, your attention. We really appreciate it. And if there are no more questions, then we would happily give you the 15 minutes back, and enjoy your day. Be safe.
Do you want me just to show you a clear picture of what happens if you don't use the right water within your process? That's why we always refer to that you use chemical-free water into your clean steam generator. I'm sure I can share one slide if that's possible.
Yeah, well, if it's possible, is Debbie around to say to us?
I think can you see the slide there?
Yeah.
Can you see anybody? Can you see the slide there now on the screen or not?
Yeah, it's pretty clear.
Yeah.
Okay. This is what when we talk about chemical-free water going into a particular generator, this particular client wanted to use just normal softened water into the clean steam generator. In a matter of months, this is what actually happened. So this is why we're very particular about this. We giving you the measures or the quality of water required in a clean steam system. If you do not use that type of quality water that we recommend, then as you can see on the slide, can occur. That's just thought I'd share that as information.
Yeah, thank you, Francisco. Yeah, and also like to say thank you to the audience that's been spending time with us today. It's really a privilege to engage with you and share our knowledge with you and possibly assist you in the future.
Thank you very
much. Yeah, thank you.